Welcome to the ET-335 SOP Karnaugh maps and VHDL lab, where we're going to cover the VHDL entry. Here I am at our Quartus software, and I'm going to build a new project. First thing you need to do is put the file, the VHD file, onto the desktop. What I did is I built a new folder, and I called it SOP, and I changed the name of the file to SOP. You don't have to change that, but it's interacting with some of the projects that I have on my desktop. So we're going to start over. So we're going to create a new project. And I'm going to do the desktop. And I'm going to select my SOP folder. And I'm going to call this program SOP. Next. And let's see if I can find my SOP program on my desktop. And add it. Next, we're going to use our Cyclone 2 again, 484, and our 20F484C7, and finish. And let's see if we could open up our file. Good. So I need to change all of these OR gate W's to SOP, otherwise it's not going to work. So all of these need to match. We need to match the program with the folder and everything, and the project name, otherwise it's going to have a problem. Let's see, and one more. Okay, and that looks good, so let's just save it. And let's go ahead, and what we're going to do is go through each step here. So we have A, B, and we need to add C and D. D is probably not necessary because it's not in the program, but let's go ahead and put everything in there so we can test it. LED is going to stay the same. And let's change our program. It's going to be not A or not B and not C. And let's go ahead and put some parentheses on here so it doesn't get confused, because this is going to be the quantity of these two. Not B and not C and not A. Okay, that should be good. So let's go ahead and compile it. That way we could put in our pin planner. Okay, so let's get rid of our compilation report. Everything looks good, and go to our pin planner. And good. So let's just go in. The first one's going to be LED, and that is going to be R20. So let's go over to R20, and that's going to be LED, and it's going to be driving VCC. Good. So let's get A, that's going to be V12, and oops, one more over, V12, and that's going to be A, that's going to be input tri-stated, and then B is going to be M22, and that's going to be B, also input tri-stated. Oops. Input tri-stated. And C is going to be L21. That's going to be C, input tri-stated. And our last one's going to be switch D. going to be L22. And these switches are going to be the first 4, but they're going to be reversed, so it appears like A through B goes from left to right. So again, let's go ahead, input tri-stated. Good. And let's go back and compile it. Good. So let's just go back in our pin planner, make sure everything transferred fine. That's good. Okay, I closed out our compilation report, and so let's go ahead and program. I have my board hooked up and it's on, and I have my Night Rider flashing, so let's go ahead and program it. And I got my USB blaster, and it looks like SOP file is there, and let's go ahead and start. And we're successful, and let's go ahead and we'll demonstrate it. Here I'm showing a map of our switches, and A, B, C, D, which would be our inputs, and switch 0 would be over here to our right, switch 3 would be over here to the far left. Down would be off, up would be on, and these are the binary inputs for 0 to 9. All of these would be valid. Anything from 10 to 15 would be invalid. So these are the correct positions in order for our program to work. Okay, let's do the second part of the lab, the divide by 2 indicator. So I'm not going to change anything because we have our pins already placed, and I'm just going to change our code. So we're going to have just not D. It's that simple when we include 0. And that's good. So let's go ahead and compile it. Good. So let's go back to our pin planner. Check. Good. So let's go ahead and program it. And we got our file and USB blaster. Let's start. It's done. And all I need to do is convert from even and odd by using the switch 0, which would be our D. So even and odd, so it's working perfectly.